So next we have XXE for Dummies. This will be Brian Myers, who's been working in security for 5 years and in software development long enough for his resume to include Borland and Netscape. He's written books and articles on Windows programming, and in his current job as Director of Information Security at WebMD Health Services, Brian guides multiple teams building SaaS web application housing HIPAA-regulated data, and he also serves on the CSIS Industry Advisory Board at Western Oregon University. Please give him a round of applause.
Thank you all for coming. Let's see, is this positioned? Can you all hear me all right? Great. I'm warning those of you in the back that although I have tried to keep the font size large, there are a few screens that are like views of a console window for the demos, and you might want to be a little closer to read those. Up to you. The title XXE for Dummies is a bit of a carryover. I'm not assuming you're all dummies. This was designed, this is an extract from an internal training I developed at WebMD. Let's see if we can get there. Oh yeah, this slide, you've heard that. I worked at some companies. Right. In 2017, the OWASP top 10 list was changed and some new vulnerabilities came up. One of those are the ones in yellow on the right. Did I just change it or? No. There we go, okay. And that's the one I'm going to talk about. So this was given to teams of software developers who had just noticed this change and wanted to know what it was about. That's the goal. I wanted my .NET teams to leave the room understanding what XXE was, how it could be exploited, what danger it represented, and have some idea how to defend against it. Those are the goals. Okay, so I'm going to start kind of slow from basics because I wanted people to be able to follow along and be sure they got what the risk was and how we got to that point. The first question is, what are entities? We're going to working up to understanding what XML external entities are. We're starting with just entities. Entities you've seen before probably. They're in HTML. They exist there too. These are some common ones. They are characterized by being short strings that begin with an ampersand and end with a semicolon. And their point is that the browser, when it sees those, will render them as something else. It'll make a replacement. And these are standard ones that are predefined. And XML has the same ones. These same strings work exactly in XML as they do in HTML. In addition, XML, and now it starts to get interesting, XML lets you define your own entities. So on this page, there's a bit of XML beginning bang entity. That's a standard thing that can appear in the document type definition section of an XML document, the DTD section. The DTD section can either be a section within a single XML document, or it can be an external .dtd file that has the definitions in it that is referred to in your XML document. That'll be important later. So bang entity is the beginning of an entity definition. XML, that small blue string there, is the name of the entity I am defining in this statement. And what follows, the green string in quotation marks, is the definition of my entity. And the way that works is that in the XML document, I can refer to my entity, beginning with an ampersand and ending with a semicolon. And the XML parser will do what a browser did. And it'll take my little text macro and replace it with the string that I provided as the definition. So I think at this point we have a demo. I taped them because I only have 20 minutes for this and I couldn't afford for anything to go wrong. But this is just running on my machine, or was when I taped it. It's a simple MVC file, MVC app, and I've pasted some XML into it. It was really simple XML. It's all markup except for the string foo, F-O-O, foo. And when I pressed parse, this page passed the XML snippet back to the back end, where an XML parser in .NET went through it to extract anything that was just text and wasn't markup. And it passed that back to the web page, which is why it says foo at the bottom. I'm going to use this page a lot, so I hope that's clear. That's just a simple setup. So let's look at what happens if you define an actual entity here. And now I've put in the markup that defines the same entity I showed on a slide earlier. The entity name is XML. I think I should be probably running this. Maybe it'll highlight for you. Yep, okay, so there is the reference to the entity, ampersand XML semicolon. That's the expression that's going to be expanded. Here's the definition of that expression, XML and the long string. And then when I press parse, what I get back is not ampersand XML semicolon, it's the definition of the macro I gave. Should be pretty straightforward at this point. All right. That's what an entity is, and a user-defined entity. And now let's look at what an external entity is. Remember, the name of this vulnerability is XML External Entity. So it's external entities where the risk comes in. XML lets you do things like this with entities. It's not the full definition, but you can see I've imagined markup where there are 3 nodes, each called chapter. Each chapter node contains an entity, and I'll define one of them for you. There's a definition of one of those 3 entities, the chapter 1 entity, and it introduces a new keyword that I didn't show you before called system. So the definition of this goes bang entity, chapter 1. Chapter 1 is the name of my entity, and then the system keyword, which tells the parser that what follows isn't just a string to put in there, it's an external reference to a resource. It's a URI. So what the parser is going to do is go try to find that resource. It will look for a file named chapter1.txt, find the contents of that file, and that those contents will be the definition of the macro. So I would pull in this. What this markup would actually do is concatenate the text of all 3 chapters. And I'll show an example of that. So here is a notepad file. It contains the first couple of paragraphs of Anna Karenina. It's just a file in my file system. It's in the same directory as the code files for that XML validator page I keep using. So it's served up from the same web server that those pages are using as I test. I am pasting in here a reference to that file. I've chosen to represent it as a URL this time to localhost, to the same place the page is being served from. There's the full definition of my external entity using the system keyword. There is a reference to that macro, to that entity, ampersand chapter 1, and when I press parse, I get the text from the file. Okay, so that I hope is clear. Everything is just the way everything I've shown you is just the way XML is intended to work, and I'm going to kind of summarize it with this. There are 3 things interacting in what I've been showing you: a user, a web page, and on the back end somewhere an XML parser. The user, me, entered some XML in the web page. The XML contains an external entity reference. So when the page passes that back to the parser attempts to resolve that and looks for the external resource. It reads a file. Then it takes the contents of that file and sends it through the web page back to the user. What could go wrong? Okay. I'll show you what could go wrong. Have a look at this markup. It's very, very similar. I've changed the name of the macro to phishing instead of chapter 1. And I have changed the name of the file I've asked for to Windows/systemini. And if I press parse, which I think I'll do here in a minute, I get the contents of the Windows systemini file. And if you aren't a Windows person, this is like XXE password. It's kind of a standard, well-known system file with some private information that has nothing to do with a web server and absolutely should not be accessible to a hacker and should certainly have not been served up in this web page. So you have now seen an XML extended entity vulnerability demonstrated. I'm going to do a better job than that. That's just a start. I was trying to make it easy so you see how it works. This is a very contrived example, and it's contrived in the following way. The thing that sort of cheats is that this web page I have designed returns back to you the parsed value on the web page. Most web pages that receive XML, or more likely most web services that receive XML, parse it on the back end but don't return it to you. They'll do something with it and then they'll give you back like an error code or a success code. So you might very well assume, it would be reasonable to assume, given what I've told you so far, that any web service or web page that isn't kind enough to pass back the parsed value for you is not vulnerable. But that turns out not to be true. So now let's look at a real exploit. And what I'm going to set up slowly is this. I'm here in advance is what we're aiming for. Very similar setup, same three things interacting. The user puts some XML, some attack XML that contains an XXE into the web page, sends it back to the parser. The parser goes and looks up whatever was referenced and sends it to another server. So it doesn't matter what it returns back in the web page where I execute the attack. I set up another server, which I've called evil.com in this slide, and get the parser to resolve a reference in the course of which it sends me the contents of another file. That's what we're leading up to. Okay, let's look at how you would do that. This little string at the bottom is the basic logic. It won't work, it's not the attack, but just trying to show you basically what we're trying to do. I want the parser to do sort of what this suggests. That is, look up the contents of the system.ini file, put those contents on a query string for a web page on my server, and send it to me that way. What's written here would actually only send the name of the file, the string. I got to do something else. I've got to put that in an entity so that the parser will go look up the contents for me. And in fact, I have to put evil.com in an entity too, so that it'll try to look up a web file on evil.com that has the query string I want in it. And this, what I have on the screen here, is close to the attack. It doesn't quite work in the way you expect, because that reference to an entity inside the definition of another entity doesn't produce the result you hope for when the DTD section where this all occurs is in the body of the file. You end up having to create a separate DTD file, and of course, how can the attacker pass that in? All you have is that one little box on the web form. There's no place to put a separate file. So the DTD file that has part of your attack has to be up on the web server, the evil.com web server, and your attack XML has to ask for that to be resolved. Some magic happens. I'm not actually going to be able to explain in the time I have every single thing that leads me to this solution, but I will show you what the solution is, and it is only using things you already understand about XML. It's using them in clever ways. So this is the external DTD file that I'm going to put on the evil.com server. It's got a nested set of entity definitions, but the core one in the middle is absolutely recognizable. That's the evil.com payload with an entity that can expand to the contents of the file I want to steal. And then the other part, this is what I will actually put into the page as the attack, refers to the DTD file, that's the red macro, and gets that resolved. The parser will actually pull the DTD file off of the evil server back to the back end where the processing is happening. And so whatever was in that becomes part of the definitions here. It all resolves nicely. Trust me, I will show you that it works. And there's nothing in that except nested and separated cleverness and definitions of external entities. Great. Here's the last spectacular demo. I hope it's spectacular. It's fun. So we're looking at the evil.com server. It's running in on Kali Linux and a VM on my machine. There is the contents of the evil.dtd file in the same directory as a default.html file. So I am going to start up the HTTP server. It's a Python script. And now let's go over to the browser and convince ourselves that the evil.com server is up and running, working the way you'd expect. There's the URL. Instead of saying evil.com, it's actually got the IP address for this VM. And it served up the default.html, so great, the server is working. More importantly, over here you can see that the Python script that is the HTTP server is showing the request. It got a request for default.html. That's important. You'll see requests it gets echoed over here, and we'll look at what those requests are. Okay, here is the attack XML. This is the same thing I showed you on the previous slide. It's going to refer to the system.ini file. That's the one I want to steal. It's got a reference to the DTD file on the evil server there. And it's got the send macro at the bottom, which is actually defined in the DTD file, not here in this snippet. I press parse. Yeah, I get some text back. Who cares? That's not the important thing. We said we're going to look at our server where we've had some more traffic. There's the request for evil.dtd. There is the request for default.html with the payload on the query string. That string is the payload, and that was the contents of the system.ini file. And I think that was clear. I heard a few gasps. I'm happy. But just to be really sure, what I did there was over on this, in the validator page, I crafted some HTML that put in it the name of a file I chose that I hoped existed on the target server. And I passed that into the target server, which very kindly, blithely for me, looked up the contents of that file and sent it to my server. So if the demos went too quick, there's a summary of what that was and why it's dangerous. Thank you. That was the climax. The rest is just, winding down. Some obvious things to ask. How can you tell if you are vulnerable? What you need to do first is ask, are you parsing XML? Obviously, if you're not parsing XML, no problem. But there are some other questions to ask too. If you are parsing XML, does your parser allow DTD sections? If it does, then is it also resolving external entities? These are separable questions, and I'll say more about that in a minute. If you are allowing DTD files and if you are allowing external entities, whether you're using them or not in your own code, if the parser you are using will allow them, then you have to ask, are you validating untrusted input? Just like with SQL injection, the question is, are you validating what you get? Do you know that the external entity definitions you might receive are safe? Validating those can be painful, and so it's a good thing to turn off those other features if you can. How do you defend against this? Well, don't use XML if you have the choice. If what you need to describe in markup can be described in something simpler like JSON, do that. That's a good defense. Oh, sorry, I didn't mean to advance yet. Page up, page, there we go. Second, if you have to use XML, be sure you have a current version of your parser, because parser companies got better at it, and they put in some safety features in modern versions that I'll say more about. If you have a modern XML parser, then see if it has DTD support disabled. And if it doesn't, disable it if you can, if you don't need DTD. If you do need DTD and it is enabled, then the next question is, can you separately disable the ability to resolve external entities? Because there are lots of uses for DTD that have no use for external entities. You may very well be able to disable that one feature and be safe. If you actually need XML external entities, then you have to validate your input. Some parsers, like the .NET one, let you attach an object to the parser whose job is to resolve external URLs. And you can then implement a policy that says, I'll only resolve things if I recognize the string or if it's part of a subdomain or something like that. I was writing this for a .NET audience, so here's a little more .NET detail. Most of the online examples are from open source stacks, so it was fun for my team to see this actually demonstrated in the stack they use. On the right are a list of .NET objects that are capable of parsing XML, and information about whether each one is safe by default, and if it is not, in what version it became safe by default. In general, the answer to safe by default version is 4.5.2, which came out in 2014. So if you're using modern stuff, that's good. What does safe by default mean? It means that the properties on the parser that allow the dangerous things are set to null or false by default. So if you want DTD in a version from 4.5.2 on, you have to explicitly turn it on. Before that, it was on by default. In .NET code, this kind of logic looks like this. You create an XML document in those first two lines. That's something that can parse XML, and it has a property called XML resolver. And if you set that to null, then it will not be able to resolve external entities. That is good. In the second two lines, I have created another object in XML reader settings, which can also parse XML, and then set a property on it to false. The property is prohibit DTD. If I set that property to false, I am allowing DTD, which is not enough to know for sure if it's invulnerable. I still have to check to see whether it will resolve external entities, but I can't say for sure that it's not vulnerable at that point. Just giving you a sense of what it's like to read the code. Closing words, we always put resources here. Where do you look for more information? And I want to shout out to Tim Morgan, who I saw here yesterday. I don't expect he's here now. We hired him, he's a local guy, to come and give some security training to our team. He's really good, and he talked to us about XXE. That's where I first learned about it. If you start Googling for information, you'll quickly find his AppSec USA talk and a paper he published on the topic, and I absolutely used these in putting together my work. And I'm happy to share these slides. That's it. There's contact information for me if you have questions or there's some way I can be useful.